So in this lesson, we're going to learn about something called polyatomic ions. You've probably heard of things like nitrates and sulfates. So when you hear names that end with ate or ite, that is going to tell you that you have something called a polyatomic ion. So let's take a look at this graphic right here, which is showing us some monoatomic ions. Monoatomic, of course, is just referring to the fact that there is just one atom involved. You've seen these before with nitride. So there's a single nitrogen here, and we call it nitride with an IDE ending. One atom here, nitrogen, has an overall charge of -3. Sulfide, right? Sulfide, ide, tells you that it's monoatomic. It's composed of one sulfur atom with an overall charge of -2. And here we see chloride. Ide is telling you you have a single chlorine atom with an overall charge of -1. Those are what we've been working with so far in class. But today we're introducing something called polyatomic ions, and we're going to take a closer look at these. So polyatomic is referring to more than one atom in the ion. And so, for example, we are looking at something called nitrate. Notice the ATE ending. There's more than one atom here. There's one nitrogen and 3 oxygens, and with an overall charge of -1. Okay, so compare that to this polyatomic ion called nitrite with an ITE ending. It has one nitrogen and 2 oxygen atoms, and overall, that collection of atoms has a -1 charge. Sulfate, right? You see sulfur in there. So there's a sulfur atom with 4 oxygen atoms hanging out together. Overall, that cluster of atoms has a -2 charge. Sulfite, 1 sulfur, 3 oxygens, that cluster of atoms has an overall charge of -2. There's an ion, polyatomic ion called ammonium. It has 1 nitrogen, 4 hydrogens. That cluster of atoms has an overall charge of +1. And here we have hydroxide, which has 1 oxygen atom, 1 hydrogen atoms, and that cluster of atoms altogether has a -1 charge. So let's do a little comparison, right? So comparing nitride to nitrate, right? So when you see the IDE ending, you know you're talking about a monoatomic ion right up here, okay? And so if we look at this, the nitride has an overall charge of -3 compared to the nitrate, which has an overall charge of -1, okay? Type and number of atoms. So nitride, with the IDE ending, this is monoatomic. It has 1 nitrogen. We would write its chemical formula as N-3, or N3-, however you like to write it. The nitrate is a polyatomic ion, right? So it has the ATE ending. That's a big clue that you're looking at a polyatomic ion. And here we have 1 nitrogen and 3 oxygens. And we would write that chemical formula as NO3. You're going to put parentheses around it because that's basically saying that you have that cluster of atoms that are going to stick together. This is a really tight friend group. This nitrogen and those 3 oxygens hang out together, and you can't break them apart. But overall, that cluster of atoms has a -1 charge. Okay, so how would we break down the sulfate? Sulfate, the overall charge is a -2. It has 1 sulfur and 4 oxygens. The chemical formula here would be SO4. That's the friend group. That's what's in this circle. Those 5 total atoms are hanging out together. Overall charge of -2. Sulfate, notice it has a -2 charge, same as the sulfate. Sulfate and sulfite, both are -2 ions. The difference here is that in the sulfite, there is 1 sulfur and 3 oxygens. And the charge here is the SO3. We're going to add parentheses here. We're going to put a parentheses around the SO3, but we're going to keep that -2 on the outside. Ammonium, notice, has a +1 charge. It is polyatomic. Many atoms there. There is 1 nitrogen and 4 hydrogens. And the chemical formula here would be NH4. You're going to keep that friend group, that 1 nitrogen and 4 hydrogens there, a tight-knit group of friends, and their overall charge of +1 is going to stay on the outside. Okay, so let's take a closer look at some of these questions. We're not going to do all of them. We're just going to work through some of these. We're going to take a look at question number 3. What types of elements, metals or nonmetals, are shown in the polyatomic ion in model number 1? So for example, what they're trying to show you here is, or what they're asking, is if you look at sulfate, for example. The sulfur is a nonmetal, the oxygen is a nonmetal. So within this ion, these atoms are all nonmetals. That's true for nitrates, nitrites, ammonium, sulfites. Polyatomic ions, yes, they have an overall charge, either positive or negative, but within this ion, we have only nonmetals. Okay, and so the reason we are bringing this up is because inside of this, what's holding this nitrogen together to this hydrogen? What's holding this sulfur to this oxygen? We've learned about ionic bonds. We know that for something to be an ionic bond, you need a metal and a nonmetal. So in this case, we have all nonmetals. So what's holding these atoms together is not an ionic bond. And that's what this next question is asking. What type of bond hold the atoms together within, we're going to change that to within the polyatomic ion. It's not ionic. Okay? They're called covalent bonds, and we haven't learned about those yet, but that's okay. The idea that we're trying to get at is what's holding these atoms together is not an ionic bond, but overall, this polyatomic ion is charged, right? This is a +1 or a 1+ charge. This ion is going to be seeking an anion. And when it does, it will be participating in an ionic bond. Sulfate, overall, this ion is a -2 charge. Even though these atoms are being held together by not ionic bonds, the sulfate as a whole with a -2 charge is seeking another positive, seeking a positive ion for it to attach to. Okay, let's take a look at another question here. We're going to look at similarities and differences. Similarities and differences between the nitrate and the nitrite. Okay, so let's take a look at similarities. Similarities for the nitrate and the nitrite. They both have a -1 charge, and they both contain nitrogen and oxygen. So they're the same charge, and they contain nitrogen and oxygen. Their differences are that in the nitrate has 1, 2, 3 oxygens, where the nitrite has 2 oxygens. So the nitrate has 3 oxygens, and the nitrite has 4 oxygens. Let's do a similar comparison, similarities and differences between sulfate and sulfite. Sulfate, -2. Sulfite, -2. So they both have the same charge, and they both contain sulfur and oxygen. So similarities, same charge, and they both contain sulfur and oxygen. The differences Sulfate has 4 oxygens, where sulfite only has 3. So sulfate has 4 oxygens. Sulfite has 3 oxygens. Okay, so now let's take that. Notice that the nitrate has more, I just realized that this is wrong. Sorry about that. The nitrate here only has 2 oxygens. My bad. Nitrate has 3 oxygens where nitrite has 2. So the nitrate has more oxygens than the nitrite. The sulfate has more oxygens than the sulfite. So now let's apply that to chlorate. Chlorate has a charge of -1. It's 1 chlorine and 3 oxygens. So if we write out that formula, 1 chlorine, 3 oxygens, overall it has a charge of -1. Okay, so that's what we are saying is chlorate. So predict for me what you think chlorite ion would look like, right? And so if the 8 has more oxygens than the ites, then we might predict that the chlorite has only 2 oxygens, but it would probably have the same charge. Okay, so there's a lot going on here that's just sort of an introduction to polyatomic ions. There's a lot that I just threw at you, but I want you to recognize that in your reference tables, we are now going to be able to access reference table E, which is called selected polyatomic ions. And if you take a look here, we can see the sulfite and the sulfate. We can see the nitrite and the nitrate. And we can see the chlorate and the chlorite. So those are not ions you have to memorize. They are listed here in reference table E. So that's good news. All right, stay tuned for the next lesson where we are going to use polyatomic ions to write chemical formulas and to figure out how to name those ionic compounds. See you in the classroom.